We are still at the Science Matter podcast live in Cape Town in the Oceanography and Meteorology Conference. Today I'm meeting amazing scientists, and one of them that I met today is Dr. Warren from SAEON, who I'll allow to introduce himself. Doctor, can you please introduce yourself?
Anytime, eh? My name is Warren Joubert. I'm a research scientist in the EFTEON program in SAEON. I've recently joined SAEON as a meteorologist. I'm always struggling saying that word.
Yes.
I'm responsible for meteorology and atmospheric composition in the EFTEON program.
Okay. I heard you say EFTEON. I'm sure someone is confused like me right now. Can you please take us through what is that?
Yes, sure thing. So the EFTEON program is a research infrastructure that is enabling the observational activity for making measurements in the environmental, it's expanded freshwater and terrestrial environmental observation network. So what we're trying to do in EFTEON is actually establish a research platform that looks at observations, from atmospheric observations, from biodiversity, ecological, hydrological observations throughout various landscapes within South Africa.
Okay, so this conference is about meteorology, the name that we cannot pronounce properly.
Yes, the tough name, yes.
And oceanography. Can you tell me the background and your interest around this field?
Sure thing, eh? So from my background perspective, I studied physical oceanography with a bent towards chemistry, where I was trying to understand the ocean chemistry to some extent and how that relates to the physical movement of the oceans. You know, so where do chemicals actually get transported to? And from there, I got some exposure to looking at the dissolved solids like oxygen and gases that is being taken up by the ocean. So I was actually looking at the exchange fluxes of greenhouse gases, for instance, between the atmosphere and the ocean, and how the atmosphere and the ocean is linked from a gas exchange perspective.
Okay, so in Science Matters, we like saying that before there's a research, there's normally a problem. So what was the problem that
what
you were
trying to understand?
Yeah.
So the so what of our question was that the ocean, similar to how trees takes greenhouse gases from the atmosphere and puts it into its biomass, so the trees grow by taking up carbon from the atmosphere. In the same way, the ocean also takes up greenhouse gases from the atmosphere. So our question was basically, what is the role of the oceans around South Africa in contributing to taking up that greenhouse gases from the atmosphere? How much is it taking up? Can we quantify how much greenhouse gases is being taken up by the ocean? Is the ocean actually putting greenhouse gases back into the atmosphere? And because the Southern Ocean specifically is a region that was not very often sampled or measured, so there's very sparse measurements in the Southern Ocean. So my contribution or role was to try and understand what is the role of the Southern Ocean in taking up some of these greenhouse gases from the atmosphere.
So from your findings, I wanted to make sure that I don't forget this question. You said you're also trying to track where is the ocean taking the chemicals.
Yeah.
What were the findings there?
So the entire ocean is connected, right? So you will have regions in the ocean that is in contact with the atmosphere, but then like at the equator, for instance. So, but you'll also have regions in the ocean where that ocean that was now in contact with the atmosphere, the water cools down. And because the water cools down, it gets more dense. So it's almost like oil that goes in, the hot water is almost like oil that goes and sits on top of the colder water, which then subducts below the warmer waters. So what happens is that when the ocean is in touch with the atmosphere, it connects to exchange gases. That gases and atmosphere then cools that water, which then takes it down into the deep ocean where it's now not in touch with the atmosphere anymore. But then in that same way, that same water that now is now subducted below the warmer water that is now in contact, it comes up in other regions of the ocean. So the ocean is connected through thermohaline circulation is actually what they call it. So in the poles, the water would sink to the bottom, and at the equator, some of that water actually comes back to the surface. So in that way, there's the sort of cycle of how chemicals that was in touch with the atmosphere gets transported in the deep ocean.
Yeah.
So that was what we basically...
As you're demonstrating, I'm getting the picture of the water cycle that we
very
did
true,
in high school.
Very similar. So the water cycle in the atmosphere, that one is basically in the ocean.
Okay.
Very similar.
Do we get affected, or lives underwater, do they get affected by this cycle, or?
Absolutely, because, oftentimes the biology or organisms, in a sense, like regions where they are adapted to that specific region. So let's make the example of phytoplankton. Phytoplankton is light to grow. So phytoplankton stays in the surface, for instance. But you also get different species of phytoplankton. Some of them are adapted to warmer climates, so they're living in warm waters. Some of them are adapted in colder climates, say like colder waters. So in that same way then, in the upper trophic levels of the ocean, you will get fish or mammals that basically prey on, the sort of food cycle that is specific to specific regions in a sense. So if you're asking how do what I've explained affect the sort of life in the ocean, there's a connection in how nutrients are available in different regions of the ocean, because colder water holds more nutrients, warmer water has its nutrients removed in a sense.
I'm starting to think of seasons. Maybe,
very true.
We have more mangoes in summer, so the cycle is giving seasons. So before I close, we always say research is for societal impact, but also, now we are talking about life in the ocean.
Sure.
How can we make it better? How can we contribute to making this problem better for the life in
Absolutely. Ocean? So my first response to a question like that would be, we have to understand. So if you don't understand something, it becomes very difficult to really manage it in a sense, or, so from a research perspective or a scientific perspective, I think it's important, and I think scientists has this responsibility whereby they have to, contribute to understanding how does what we are doing on a day-to-day basis, in the way that we are living our lives, how is that affecting the ocean? Because ultimately, in the same way, if we are having a negative effect on the ocean is on the same way affecting back on us and the atmosphere for that matter as well, So my first answer to that question would be, we have to understand first off. And once we understand, we have to ensure that there's, that people that make decisions about how we should manage our resources, have the appropriate information that can help them make good decisions about how we're managing our resources.
Okay. Thank you so much for your time. Any last words, and what are you looking forward to in this conference?
No, it's, for me, the conference itself is very exciting because we are at that interface of having both the atmospheric researchers and the ocean researchers interacting and discussing what it is that is specific to their fields and how that can be, how they can be complementary to each other. That's the one thing, to see what it is that other people are doing. And particularly this conference is also focused on the Southern Hemisphere researchers. So it's basically the Southern Hemisphere community that is getting together and getting a better understanding of, all of the issues that we have within our respective regions of interest.